I'm CK. Today we have another kit from Velleman. This time it is their 3-channel RGB LED light organ. So that sounds like it might be pretty much fun. We'll put it together, play with it a little bit, and see how much fun it is and how much we learn. And I hope you enjoy the video. Here's the box. Typical Whadda Velleman box. Here's, and on the front it says it is focused on LEDs. It also says practical soldering gadgets, so it's not just for learning, it's for doing something with. Soldering, it's a level 2, which should be really easy. Works with 12 volt or 24 volt LEDs or LED strips. Ah, okay. So it looks like it can drive stuff. Easy cabinet panel mount. Max 1.2 amps per channel. That's pretty high. And the front dimensions. So I guess this can drive a bunch of LEDs, which will be pretty cool. We'll see what... I don't know if I've got any strip LEDs handy. I might. I'll look it up. So let's open her up and see what's inside. Not a whole lot. Ooh, interesting purple circuit board. Okay, we've got, the values are not listed. There's a bunch of diodes, some potentiometers, transistors, capacitors, bunch of resistors, even though I hope they're quarter amp resistors or quarter watt resistors, because the holes are very close together. If they're half watt, I'm going to be frustrated putting them on, so I'm going to make an assumption that they're quarter watt. Looks like there's some power coming in there, power coming in there. There's a switch, I think, over here, but I'm not certain. And then something over here, which I don't know what that is right now. Let's look at the front panel. So there's a microphone. So what it's doing, why am I over to the side in the camera? Hold on. Camera shifting. There we go. Sensitivity and a microphone. So it's picking up whatever audio is in the environment and pumping it out to low frequency as red, mid frequencies are green, high frequency is blue. Well, that's pretty interesting, isn't it? That'll be fun. Little sheet to go to the online manual. Let's dump all this stuff out. And yeah, they are all quarter watt. Good. So these are the diodes and resistors. And the way Velleman does this, which I really appreciate, is they will put them in order of assembly. And the other thing they do is they put all the components and all the different value resistors on one strip in one package, so you don't have a whole bunch of little bags, which drive me crazy. There's a bunch of transistors. These are 547Bs, and some, I think these are 270s. Gosh, I can never read the gray on the dark blue. Aggravating. A couple of 472s. And a couple of 557 Bakers. Big ol' voltage regulator with a barely discernible part number. I can't actually read it. It's as if somebody scrubbed it off. Why they would scrub off the part number on a common voltage regulator, somewhat baffling. Some electrolytic caps. Here's a microphone. Pretty standard. I've seen these a lot. Oh, here looks like another voltage regulator. Nope, that's the one I already looked at. Terminals. I assume they're terminals to go out to the LED strips you're using. I may hop on Amazon real quick and order some, and maybe it'll get here in time for me to do this, or I'll hold this video until I get them. Here's the potentiometers. It'll go here to set the sensitivity, and here are little knobs, shafts and knobs that go in those pots so it's easy to control them. Here is another tiny blue cap. I'll look at that much later. Some heavy-duty screws. I assume this is to allow you to, there's a spacer, and that's the way it's going to mount all together, I'm assuming. And then one big knob for sound sensitivity. So that's it. It looks like it's pretty easy to put together. So we'll do that. I'll get the soldering iron heated up and we'll fling this thing together. A couple of days later, and I got some LED strips, green, red, and blue, so we'll be able to make this thing do its thing in a little bit. So I've got the build guide up. So again, the resistors are all in order, so the first thing we're going to be doing is 10 1Ks, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1Ks. So I'm going to pull them off the strip. So let's see how this board takes solder. I have not used this particular board type before, this purple material. I'm sure it's just fine, I just haven't used it. So we're going to go through and put one in, and these are all 1/4 watt resistors, and the holes on the board are spaced for 1/4 watt resistors. So you want to bend the leads as close to the body as you can, so it goes in the holes well. We'll do one right here. Okay, soldered on very nicely. Now we'll go ahead and do all the rest of the resistors, and there's not much to say about all the resistors that I haven't already said. We've seen how they come in the packaging, and we've put one on to see how they solder the board, and they solder very well. So I will be putting all the resistors on in fast motion playback, and I'll probably cut out some of it too. And while I'm putting them all on, I'm going to be listening on WQXR FM's iPad app. I'm going to be listening to Symphony No. 1 in C major by Joseph Leopold Eibler from the Geneva Chamber Orchestra, and Michael Hofstadter conducting. So enjoy resistor time. And that's all the resistors on the board. Let me turn it right side up for you. We've still got some stuff on the strip. We've got some Zener diodes and one polarity protection diode, so let's take them all off. These are the 4148s, the Zeners, and this, I always forget the part number of this one. 1400, 4007, that's what it is. That's the protection diode. So we take our diodes and we put them in the positions marked ZD1, ZD2, ZD3, and probably ZD4, but where is it? There it is. For Zener diode, there's a black line, goes with the bold white line on the circuit board. If you're building a project like this, and when you power it up, it doesn't work, first thing you want to check is to make sure you got the diodes in the right polarity, because you can easily make that mistake and then things won't work. And generally, if you just desolder it carefully and switch it around, it'll work just fine. But if you are going to desolder these 4148s, you will want to be very careful, because they're little glass cylinders and they can indeed break very easily if you try and apply any force at all as you're trying to pull them out of the circuit board. Now, where does this go? So the power comes in here. So if the power comes in here, then there. The diode has got to be close to wherever that power comes in. Now, they used the same width for this diode as they did for the smaller ones. Actually, they didn't. I'm going to stand this one up on end. I don't like doing this, and I hope it'll fit. I'm going to check to make sure if I'm going to put one of these variable resistors in, just to see if this will fit. It looks like it will. Let me look at the picture. Why don't you look at the picture? And yeah, they're standing up too. Okay. So my instincts were right. I'll solder those diodes in place. There we go. All the diodes are in. And that took care of our strip of material. Now we're going to put some decoupling caps on here. Actually, I wonder why we're doing that, but we are. Some 104s. I think there are 3 of them. Let me dig those out. Here they are. I'm groaning because these are the horrible light gray on blue printing, which I can barely read. So just in an abundance of caution, I'm putting them on my meter to see what they're looking like. 98 microfarad. I mean, 98 nanofarad. I mean, 98 nanofarad, for crying out loud, which is close enough to 100 nanofarad for me. I've got a 220 nano somewhere. There's only one of them. Oh, again, it's pretty sure this is this one. Let me put it on the meter just to be sure. Again, I only do this because I can't read the freaking printing on here. So that comes out at 216 nanofarad, which is close enough to 220 to be accurate. And 2 470s, or 4.7 nano, whatever. Those I at least can read. Black printing on I got that wrong. I put this in C3, where this actually goes in C5. Got the 2 electrolytics, 110 microfarad and 100. The 10 goes at C7. And it's right here, and a very clear indication of where positive leg goes. Same as C8, very positive indication of where the long or positive leg goes. And that's all the caps, so we'll solder them down. So that's all the capacitors on the board, and as you can see, the capacitors are taller than the diodes, so obviously we're not going to have any problem putting the fitment on correctly. So now we're going to put all the variable resistors on. I don't even know if this is marked with the value. Yeah, it is. These are 10K. I guess they're 10Ks. So they fit very loosely in their slots. So I'm going to do what I usually do with components like this, put it on the board, don't care what it looks like right now, solder one leg, flip it over, and as you can see, it's at an angle, so I just press on it lightly with my index finger behind the board and reheat that solder pad, and it flattens right out. We'll do that with all of these. And now we'll put the transistors in, and we've got 3 big ol' MOSFETs. And for the MOSFETs, because they've got the big old heatsink on the back, the heatsink goes like a diode where the heavy white line is. Do we want to lay these down? I guess we don't want to lay these down because we've got to put the electrical connector in there. Okay, so they will be standing up. No heatsink, no additional heatsink is included in this. So, and I know I didn't do the rest of the variable resistor legs yet. I want to get a bunch of stuff together before I start doing all that. So I'll put all these 3 MOSFETs on. Now we'll put some NPNs and some PNPs. We've got 5 NPNs and should be 3 PNPs. There's the other one. So we'll do the NPNs first. Now we'll do the PNPs. Now before I solder all these transistors down, I'm going to do a quick check to make sure I've got the flat side pointing to the flat side on the circuit board, so I don't have something in wrong. Now we're going to put the screw connector, where we'll be putting the wires in for the LED lights. I want to make sure these are all the same. Yeah, these are all the same. Kind of button up against these MOSFETs. Got to bend the MOSFETs forward a little bit. Well, that's not good. I mean, it's not going to hurt anything, but I should have done something differently there. Moved the MOSFETs in a little bit. And 12 volt power in goes over here. And then we also have a DC socket, so if you've got a power supply already set up for 12 volts with a center positive terminal, you can put that on there and use that instead of a bench power supply or something like that. So I'm going to do the same thing here as I did with the variable resistors. I'm going to do one leg, just a little bit of solder, take a look at it, and as you can see that's very offset. So I will heat it up, let it cool, and now it's wonderfully positioned. And now we're going to put the microphone on, and it doesn't go on this side, it goes on this side. And you can see there's an opening for the slot on the microphone itself, so you are sure that the polarity is right if you got the slot in the right place. Now this is a little tricky because you got to reach between all these components to solder these, but just take your time and keep your soldering iron vertical. You'll be fine. I'm not going to trim those leads in there. That will be a-okay. Sorry, I had a little camera glitch while I was putting the knobs on the shafts, so I didn't capture that. But I do want to say a couple of things. First, you want to make sure that you do it the way they say, so the dots are lined up with, they're all consistently lined up across the device. The other thing is, the guide author says you want to have 15 millimeters between the knob itself and the base of the shoulder of the shaft. That's not much. You don't have to tap these on very far at all, so just be careful. And they're also not very secure this way. I would probably have either, because it's all gated by these spacers, and I probably would have made the spacers a little shorter, because I'm not sure how well these knobs are going to stay on. And as you can see, they're not quite even because the knob isn't pushed down far enough on the shaft to align the knob correctly. My phone is buzzing. Shut up, phone. So we'll put those on like, let me get this one in there. I may have to, oops, and that's a spacer, never mind. Now they should be, what the hey? I need to, see, they're all wobbly because there's not enough shaft to align the knobs. So they're not, this is kind of a mess. But I'm not going to worry about it. I'm not going to fine tune it much more than that because I don't need to. Because again, the key thing is right here in this picture where it shows 15 millimeters. It's just not enough. It's not enough depth. I've got all the knobs on. That all looks good. And now we're going to drop the LEDs, and I think we want to go yellow. The LED. There they are. Now you're dropping them in from this side, so you have to look at the other side to make sure you've got the polarity right. They've got a real clear indication of where the flat side, negative side is. Now we're not going to solder these LEDs quite yet because we've got to put the panel on first. Now interestingly, in this picture you can see whoever did the shots for the manual had the same issue I did. He had to bend the MOSFETs back off that wiring block because they're don't have enough space. Okay, now we're going to take the front panel. We've got LED holes there and a position for the microphone, and we're going to try and put this on around the kind of cattywampus knobs, and we'll put a screw through here and put a spacer on it like so. Now we'll get it all the way over here, and I'm going to put one of the nuts on, just finger tight, not even halfway down the threaded shaft, because I want to have a little room to play around. And we'll do the other 3 corners. Now, to finish the soldering, we'll take the LEDs and push them forward through the holes in the front panel. They don't go all in the same way, they're not all the same diameter. That's a little sloppy too, not a big deal. So I'm just going to set that there, rest it on that, and I will solder the LED leads. So that's all the LEDs, and that's the way it looks this way. Seems to work okay. Now I'm going to get set up to actually test this. Actually changed my mind, and I actually fixed, replaced the batteries in my microphone, which is very good, so we can switch back to the good quality microphone. What I'm going to do, as we saw on the back here, there's a common positive terminal here, and then a blue, a green, and a red ground terminal. So what we're going to be doing is I'm going to gang the positives all in one bundle to put in there, and I'm going to solder them together instead of just trying to twist them or whatever. So I'm going to split that out, and oops, golly gosh, it's wiggling onto the ground like a very snake. As I said, I'll gang all the positive leads together, and I'm also going to solder. Go ahead and put them in while we're here. That's wide open. So the 3 positive leads go in the terminal marked with the plus sign. Now we'll take the red one and put its negative lead in this end slot. I think they're all good enough. Now I got to go get a power supply back in a second or two. Okay, I've got the benchtop power supply hooked up, and when I tested this, when I tested the LED strips when they came in from Amazon, I ran them, they turned on at about 7 volts and turned back off, and I ran them up to about 30 volts with no problem. So I'm going to go ahead and dial in, let's say 18 volts. Ooh. Well, at 15 volts, as you can see, it's picking up my voice very well. The only thing it's not getting, it's got the low, which is the red, the mids, which is the green, and it's not getting any of the blue, which is high frequency, because I'm not that high frequency. Let me squeak a little bit. That didn't work, did it? But it did show up a little blue. Let me turn the sensitivity. There we go. Worked just fine. I'm going to go ahead and play some music of mine. So you can see the red lights reacting to the bass beat, the boom. The green is the only one I'm a little, have to turn the sensitivity up a good bit for that. But there you go, that's what it does. Works pretty well, and you can of course chain these LED strips together. There are contacts under the adhesive here that you could chain to the next strip with. Put them in a bookshelf, put them on your car, put them on your tricycle, whatever you want to do, as long as you've got at least 12 volts to power it. Even though, let me drop this down. Now we're at 11 volts, 10 volts, oh, 10 volts, it's starting to fade away. 9 volts, yeah, it's the power of this plus the power of the LEDs. You need at least 9 volts, 10 volts. But that's not important because you're going to want to run this at minimum of 12 volts anyway. One other thing I'd like to point out is the MOSFETs are dead cold, but this is a completely non-integrated circuit build. You can learn a lot from how it's pulling out the various frequencies with the resistor bridges it's building here, and learn something good from that about frequency division and using voltage from that out to to segment it. It'd be an interesting thought experiment, and you could look up some resources and try it with this. But in general, it's a fine kit. The knobs are not fine. They need to do that better. But other than that, it works very well, and it's a fun little kit. And I hope you enjoyed the video.